Assalamu alaikum and good afternoon, everybody. This is Nafisa bint Prabha, Research Associate of DIGM, and I'm very pleased to welcome you all in today's research webinar by Reform, episode 12. Dear audience, I'd like to share that Reform is the research networking arm of Bangladesh Institute of Governance and Management. The objective of Reform is to form and develop an international standard research platform with Bangladeshi and international scholars and researchers at its center. It covers different research disciplines and domains such as public policy, economics, healthcare, environment and climate change, data science, and so on. It promotes interdisciplinary research and learning and finally encourage the dissemination of knowledge of the research that is offered by this investigation. On this research webinar, today we are delighted to have Ms. Sabrina Rashid Sheonty. Ms. Sabrina Rashid Sheonty is currently working as a water resources engineer in Matrix Solutions Incorporation, a renowned environment consultancy firm in Canada. She completed her bachelor's and master's from Bangladesh University of Engineering Technology in Water Resources Engineering and obtained her second master's in Transportation Engineering from University of Alberta. She also served as a faculty member of Military Institute of Science and Technology. Her research areas include water, hydrology, environment, and climate change. She has done various hydrological modeling, flood studies, hydrotechnical design, and stormwater design. She is the founder of Tetra, a social innovation startup aiming to provide innovation solutions to ensure safe drinking water access for the underprivileged coastal community of Bangladesh. She has profound research experience and published over 20 technical journal and conference papers till now. She brings a wealth of knowledge and experience to the subject of the matter today, and her insights will provide us valuable perspectives on the feasibility study of solar desalination device to solve drinking water salinity of coastal Bangladesh. With this, let's start today's webinar. Dear audience, you are requested to mute your microphone during the presentation. At the end of the presentation, you will be given the opportunity to ask questions by using the raise hand option in Zoom. Please note down any questions that you have to ask during the question answer session. Now, I would like to welcome Ms. Sabrina Rashid Sheonty. At first, I'd like to thank you for your time and effort today and for accepting the invitation to speak at Reform. You are now requested to share your screen and start your presentation. The floor is yours.
Thank you so much, Nafsa, for this kind introduction. And I'd like to thank Reform for inviting me today as a speaker. And today I'm going to talk on a very important topic. So without any further delay, I think I can start. I think you all can see my screen. So Nafisa has already introduced me. So I'll not go into detailed introduction of myself, just a small intro. I'm Sabrina. By profession, I'm a water resources engineer. And from talking of my educational background, I have graduated from BUET with a degree of water resources engineering at 2018. Then I did my back-to-back master's in water resources and transportation engineering from Bangladesh and Canada. And apart from my professional bonding with in a consulting firm here in Canada, I work as a director in one of my founding organizations, Tetra, that works for ensuring the access of safe drinking water for coastal Bangladesh. And under this organization, we are doing a lot of research activities. And today I'm going to present one of our core research that is based on one of our flagship product, that is Solar Desalination Device. And today my topic is to just explain you about the feasibility study of Solar Desalination Device to solve the drinking water salinity of coastal Bangladesh. Basically, I'll introduce you to the problem of salinity that exists in coastal Bangladesh, and a brief introduction about Solar Desalination Device and how it can help us to solve the drinking water problem in coastal Bangladesh. So without any further ado, I think I can start. So today I'll talk a little bit about the problem statement, the salinity problem of Bangladesh that exists for a long time and how it's going to be amplified due to climate change. Then I'll explain about the objectives that we had for this study. Then I'll talk about a little bit about the methodology that we had for conducting this research, and how the solar desalination device can be a very helpful tool to solve the problem statement that we have stated before. And then I'll talk about the resultant discussion we have got from the study. And at the last, we will conclude about is the solar desalination device actually feasible for the as a sustainable solution in the coastal region of Bangladesh or not. Then we'll have the reference of the study. So talking about the problem, we all know the importance of a safe drinking water source under this heat wave, right? Because we all know like how the changing climate can look like. And under this changing climate, the salinity problem can be very amplified in the coastal region of Bangladesh. And that is one of the main reason why we are facing the lack of access of safe drinking water for our coastal people. So if you see the map that I'm showing on this slide, you can see like the salinity level of Bangladesh is on an average on 1,000 milligram per liter, which is very high in the comparison of the salinity concentration that is directed by World Health Organization, WHO. So only for this problem, even if we have a huge quantity of water present in the coastal region of Bangladesh, but this water is not drinkable at all. And 43 million people who are living under this region, they all are suffering from this problem. So talking about like how many districts are under this region and how big and big of a community is suffering this problem, I can give you some data and statistics. It's like 47 kilometer squares of covering 19 districts actually under this salinity region. And around 43 million people who are living in this region are suffering from less to high salinity. And due to this problem, all of their water sources, groundwater or surface water sources, has become saline. And as I have stated before, that Bangladesh is one of the most vulnerable country for the impact of climate change. And recently, Bangladesh has been ranked as 7th due to the vulnerability as the vulnerable country under the effect of climate change. So this problem, the salinity problem, is going to be very much more impactful and worsen in the upcoming future. Because as we know that climate change is going to have its worst impact on water and environment and weather, of course, that you are seeing as today as the impact of heat wave. So stating these problems, we have got an understanding how big of a problem salinity is. Now, let me talk a little bit about like how it is directly impacting the health and socio-economic status quo of the community people living in the coastal region of Bangladesh. Basically, if you consume this saline water for a long time, it can have very adverse health effect in your body. It can induce cardiovascular diseases, diarrhea, abdominal discomfort, and other health hazards. For pregnant women, especially for women of growing age, particularly this saline water has a very adverse effect. It can generate preeclampsia, eclampsia for the pregnant women that can cause the pregnant women's discomfort and also causes death. And there has been many research data we have found through this research that I'm going to share in my next slides, that it has been a very important cause for the death of pregnant women in Bangladesh in the coastal region. And talking about the socioeconomic problem, it's not only impacting the health hazards in this coastal community. There are impacts in some socioeconomic parameters like in their livelihood, education, etc. For example, like for avoiding this salinity problem, people have to walk a long way in order to collect safe drinking water for their family. And basically, women or small children who are girls are getting the responsibility of collecting this drinking water from a very distant point. And that's how many of the girls cannot go to school because they have to collect the drinking water for their family. So understanding the course of this problem, it's not only the health hazards, it's impacting the gender discrimination, it's impacting the education of girls, and also some of the safety issues that we have seen in the social context of coastal community. So as this problem is just existing for a long time, haven't somebody has thought about any solutions? Yes, there are some existing solutions that prevails in the coastal Bangladesh, but they have some loopholes. For example, the best alternative that exists in the coastal region of Bangladesh that community people use a lot is rainwater harvesting. But as we know, like it's extremely nature dependent and seasonal, and you have to store the rainwater for a long period of time for the whole year. And that can cause some contamination in the storage. And we have seen some of those bacterial and virus contamination in the storage of this rainwater collection. So if your rainwater storage collection has been contaminated in a way, it's very unsafe for you to drink that water. So that is some of those loopholes that we have found in the rainwater harvesting system. Apart from that, in coastal community, there are some of those big desalination plants, but as those plants are very big, they cannot have those plants everywhere in the coastal belt where there is salinity problem. There are a very few desalination plants, and the problem associated with those plants are like they are very energy intensive, and as it requires a lot of power, the production cost is also very high. And as I said, the number of these plants are very few, so people have to transport this water to the remote places, and this transportation of water makes the water per unit water cost very expensive. So due to this expensive transportation and distribution system, the per unit cost of the water becomes very high, and people also have to walk a long way in order to collect this water. So that's how the problem does not really solved into a great extent. So here we have come with our unique solution, that is Solar Desalination Device. We wanted a home-based device where we wanted to provide the customer or the users that they can have their own water solution in their home and do not have to walk a long way. And the second thing we wanted to target, that they can use a renewable energy source that will be cheaper in the cost for the water production, and also will be environmentally friendly, because as we are going towards an era of renewable energy source, we wanted to cut off a lot of sources of fossil fuel, right? So that's why we wanted to use some of the renewable energy source, and solar power has got our attention. So we designed a solar desalination device under the under the banner of Tetra. And this unique desalination device uses the reverse osmosis technology after harnessing the power from the solar, and it desalinates and purifies water at the same time and can give the access of pure, safe drinking water to its users. So particularly, we have tested a lot of prototypes, and the prototypes that you can see in this slide, basically, it has an output water source at the very top of its head. And there is a solar charge controller connection that basically controls that how much solar power will be acquired in the battery, and it will be used for the reverse osmosis technology. That is the particular technology that's used for the desalination. And there is an RO system, which is attached after the solar charger controller connection, which basically purifies and desalinates the water. This is the RO system unit. And there is a battery and solar panel attached with this whole system. Basically, this solar panel is attached at the rooftop of the house, and the connection is attached with this solar desalination device. And after harnessing the power from solar panel, the energy stored in this battery, and with this controller connection, it actually controls the amount that is needed in order to, according to the requirement of the water demand of that family. And a 30-liter of water collection jar is also connected in order to store the water if they want immediately, the water demand rises if some guest comes or they have to drink a lot of water in a very hot day. So we have the facility of attaching a 30-liter of jar. Otherwise, they can from this jar, they can just have this water from this output water source when the switch is on. So talking about the capacity of this device, basically it can produce around like 500-liter water per day. So it's very, just enough to serve a family consisting of 5 to 6 members. And this size of this device is basically not that much, huge. So it is designed in a way so that it can be placed in a household level. And the power consumption for the daily maximum capacity, that means if you want to produce 500 liter per day, it costs around a power consumption of 4.32 kilowatt hour. And this power requirement changes with the production of the water. For example, if somebody's need for a day is 100 liter per day, the power consumption will be accordingly. And the filtration unit will be also, just wasted accordingly. So that's how we control the desalination range, or I would say the desalination process, based on the water demand of a family in a daily basis. And talking about the unit price, right now we are working on the prototypes and we'll be commercially launching all those products. So whenever this products will be commercially launched and we can manufacture a lot of products in a very small, production time. So we are hoping to decrease the cost, but right now the unit price of the cost is around like 26,000 Bangladeshi taka. And currently this device need the replacement only in the filters, as you know, like as you desalinate the waters, the RO system units filtration, because it's a membrane-based filtration. So you have to change only the filters. So it costs annually 1,000 to 1,200 BDT, depending on how much the RO system has been used. So if you are having a small family that is only 3 to 4 members, this replacement cost will be lower. And after sales service, we usually provide like a free maintenance and technical support up to 3 months of the installation. So if any malfunction or any problems just arises in this device, we try to have those technical assistance available for them with free of charge. So this is kind of the desalination or filtration process that happens within the just filter. So if you have the input water from the water reservoir, actually we have, as we said, a battery and a DC pump of 12 volts. So it basically helps to get into the water into the first filtration unit, that is a PPF filter unit. It basically helps to just remove if there is any suspended solids or like big particles in the water. And with a low pressure switch, it basically goes to our second unit, that is a CTO filter unit. And basically the CTO indicates chlorine test and odor. So as you can understand, the CTO filter unit actually helps the water to remove the improve the chlorine concentration and improve the taste and odor of that water. And after going to the ultra fine depth filtration, we just impose this water through a valve, and after going with the power of the high pressure pump, it afterwards go to the RO system. So by the time the water reaches to the RO system, it is the suspended solids or like the taste and odor of that water is already improved. So in this reverse osmosis system, it basically desalinates the water with a membrane system. And this reverse osmosis, I think some of you are familiar with a lot of desalination procedures. So basically there are thermal desalination procedure and membrane-based desalination procedures. So RO system or reverse osmosis system is basically a membrane-based desalination procedure. It basically helps to desalinate the water with the help of the membranes. And after having like a concentration difference between the membranes, it just just induce the water into a very high pressure and helps to just resolve the salinity concentration or the chlorine concentration into one part of the filter membrane. And after going through this RO system unit, the purified water gets to one unit where the high pressure switch is again just activated, and we have a post inline carbon cartridges, and there are some of the stages where we pass the water in order to make sure we have everything according to the standard of like the WHO and the other standards that we follow for the drinking water parameters. So we have talked a lot about like the solar desalination system and the solar desalination device. So you guys have a little bit of idea right now about which product I'm talking about. So the key objective of this device was to propose this home-based desalination device to everybody as a solution of the salinity problem that exists in the coastal Bangladesh. And the second important objective that I'm going to show in the next part of my presentation is to assess the feasibility of this device as a sustainable solution of the salinity problem. Because it's very important to understand that whenever a technology is introduced, if it's implementable or not, if it's acceptable from the user's perspective or not, if it's user-friendly or not. So that feasibility study is a very important criteria in order to understand if that product is a proper market fit or not. So this study basically, just targeted on that. And in order to conduct this study, we have chosen one of the very high risk area that has been identified in many research for the salinity problem of Bangladesh, that is Khulna. So basically, we try to have our, just conducting these studies in the high salinity affected areas of Khulna, that is Dako, Botiaghata, Dumuria, and the other northern and western side of Khulna. So talking about this methodology, how we have designed that study. So basically, at first, we tried to review the previous studies about the salinity problem. So we have studies like which area is like most salinity affected, how it's impacting the coastal community members, and if there are any existing studies, which describes about some of the solutions. So we have done an extensive literature review for particularly the first step of this research. And secondly, we have, after understanding the scenario based on the secondary data, we targeted to collect some of those primary data set in order to validate and understand like the scenario that has been described in the previous studies actually prevails in this current time or not, or like it has been amplified in the effect of climate change or the other parameters. So for that, we have conducted a preliminary research that helped us to get an
ওকে, থ্যাংক
idea
ইউ।
about
আপনি
like
ওই এক্সাম গুলো দিয়ে দিন যেগুলো মিস করেছেন।
current
মানে
scenario
আমি চাই আপনার তো লাস্ট সেমিস্টার, আপনি পাস করে যান।
salinity condition that exists in the coastal Bangladesh. So conducting these participatory research methods, some of those field surveys, we have gotten very, just very effective and very informative idea about how the current scenario of salinity looks like in the coastal Bangladesh. And at the very last point, we have tried to study the feasibility of the solar desalination device in terms of two things. The first one is from users' perspective. That is a social condition, understanding the user's socioeconomic behavior and other parameters that actually impacts their decision-making power in order to purchase the solar desalination device. And the second one is the technical feasibility in terms of like if the output water is actually drinkable or not according to the current standards that has been described in the world, according to the World Health Organizations and the national standards of Bangladesh. So after reviewing a lot of research studies, we have found some important data. So in terms of like salinity condition, as I have described before, like climate change is going to be a very important context or very important parameter that is going to be impactful in the future context of Bangladesh. Because as Bangladesh has been ranked very vulnerable as one of the very vulnerable countries, which will be impacted to the adverse effect of climate change, and it will have a very adverse effect specifically on the coastal area of Bangladesh. The mangrove forest of Sundarban, the groundwater resources, the surface water resources, the biodiversity, everything is going to be in threat for the impact of climate change in the upcoming years. So we have found like by 2050, the sea level is going to be around 0.3 meter of height. And as the sea level will be increased, the salinity intrusion in the groundwater and the freshwater sources will be also increased. And that's how the freshwater zone will be decreased by around 3.44% in the near future in the coastal region of Bangladesh. And by this year of 2050, as the increasing salinity intrusion, the soil salinity will be also increased by 39%. And that too can have a very disastrous impact on the agricultural sector of this region, because the paddy production, the rice production, and the other sweet crops that has been produced by that time in this area, this particular soil salinity increase will hamper those crop productions a lot. And due to this cyclone that you can see in this past years, there has been very significant cyclones and tornadoes in the coastal region of Bangladesh. And whenever there is this sort of natural calamities, the Bay Area overlaps with the drinking water system. So that's how the salinity intrusion is going to be more, as the frequency of the cyclones is going to be more in the near future. And The aquifer saline zone, right now, that has been indicated by some of those research that where are the areas where this aquifer saline zone is. But in near future, by 2050, this aquifer saline zone is going to be increased by 2.27%, which is a very significant cause of our stress, because according to this increase of salinity zone, we are going to lose the freshwater aquifer resources that are available, which indicates that people who used to have like some of those tube wells in order to get those fresh groundwater sources, they are going to suffer a lot, and they have to also be the victim of like collecting the freshwater sources from very remote places. And lastly, the climate sensitive diseases, like according to the report of IPCC, those are going to be increased a lot as those are waterborne, and with the increase of this lack of safe water, access, this climate sensitive diseases, the waterborne diseases are going to be increased as well. So after reviewing this information, we have understood the severity of the salinity problem that exists in Bangladesh. And after that, we tried to have to validate these data sets with our field presence and field surveys. So we have conducted a lot of participatory research, and under this, we have followed some of those very defined and standard methodology that has been introduced for a long time in the research community. We have done a lot of key informant interviews to some of those particular individuals who are in the responsibility of the community. For example, the chairman, like some of those NGO workers who are working here, who are aware of this problem and who can describe this problem from their perspective. So we have done those key informant interviews, KIIs, with a semi-structured questionnaire that we have prepared from that idea that we have got from the previous research and the secondary data sets. We have also conducted focus group discussions. Basically, this FGD or focus group discussions is actually a methodology where we just conduct this sort of research within a group of people of 7 to 8 members who are particularly have come from the same background. For example, you can do this FGDs with a low income group. So you can have kind of similar mentality or perspective from that particular group. You can have the FGD from a women's group, so that you can understand how women are suffering. So understanding the importance of the perspective of different community people. So we have conducted the focus group discussions among us, the women participants, among us, the low income group, because they are the worst sufferer of the salinity problem, and they have to consume that saline water for long term, and they are having the worst health impacts in future when they get old. So we wanted their perspective to be present in our research. So we conducted that. We also did some of those resource mapping. Basically, this is a tool to understand what are the socio-economic resources or the physical resources available in that community for them. For example, the resources can be schools, water collection areas, ponds, then what are the infrastructures that's present inside their community, and how long they have to walk to collect drinking water for their family, so that we can have a holistic idea about their lifestyle, how they're commuting, and how much they're earning, everything. So with those participatory research method, we have collected a data of around 201 households, and we tried to sort these data and analyze those data based on the analysis. We have just understood some of those key perspectives that is present in the current scenario. So before going to the analysis and the result that we have got from those data sets, let me just introduce about the percentage distributions of the respondents. So the first figure, you can see that is percentage distributions based on the villages or the areas where we have gone. We have covered a lot of areas in Khulna, like Shekhpur, Terokhada, and Chalna, Shurkhali, and Durgabati. So a lot of areas where there is a salinity problem, we try to reach those areas and try to have the perspective from the household users. And you can see about like the data sets is quite uniformly distributed. So we kind of try to have like uniformly distributed idea so that no particular community is left behind. We try to capture the idea of like people that is spatially distributed everywhere. The second thing is we try to catch the percentage distribution of our respondents of people having a variety of ages, because we wanted to collect the perspective of youngsters, the middle-aged women and men, and also the aged people. Because we have understood from our secondary researchers that perhaps the elderly ones who are consuming the saline water for a very long time are like the worst sufferer of that salinity problem in terms of health impact. So we try to understand their perspective. For the middle-aged women or like men, so they are having the problem in terms of economical perspective, because basically the area where we conducted our research, they are basically low-income communities. So but they have to pay a lot of money in order to buy or collect that safe drinking water. So we wanted to understand their perspective from that economic restraints as well. And for the like children and like the teenagers, we wanted to capture their perspective as well if they are also facing some problems. So we try to capture the thought process and perspective of like different age group, and our data sets indicates like we have got a little bit of uniform perspective from all the age groups. And also another important parameter that we wanted to ensure, like the female participation of the females of these coastal communities, and we tried to just conduct the the questionnaire survey and also the FGDs for the females as well. So that's how we try to just have some of those female participants in our research, so that we can capture the thought process of the females as well. So talking about right now the survey results that we have got, at first we try to understand like what are the water sources they're using currently, and if they're satisfied with that or not. So most of the respondents who talked with us, they are not satisfied with the water quality that they are drinking right now. So we have found like a huge amount of people like collecting the water from the ponds because they have no other water sources available in the just close proximity of their households. So they collect the pond water and try to have some regular filters to just filter that water, so that the suspended solids or like the contaminants can get removed, and then they drink that water. So basically in terms of like the salinity and also the contamination perspective, their water is not safe. So 38% people drink that water, and also a huge percentage of people drink the tubal water. But understanding that the aquifer of the groundwater resources are quite saline, so the water they get from the tubal, in some places where the salinity is less, they get a good quality of water, but in other places where there is like saline aquifer zone, they don't get the pure desalinated water. So by force they are drinking that water. And also little bit of people Also, 10% of the people are just having their drinking water from the rainwater harvesting system. The storage they store for the rest of the year after the rainy season, and they use some of those filtration techniques and they just drink that. So from this perspective, we have got like what were the water sources that currently the community people are using. But the most of them were like understanding the problem, like using a simple filter does not ensure them the access of like desalinated and pure drinking water. So when we were talking about like they are not happy with the water quality, but how much they're paying for this water, that information surprised us. So we try to categorize people based on their financial and the monthly income. So you can see the graph, like people who are like earning a little bit of more money have the luxury to spend that money for their monthly water expense as well. But we have seen a very tremendous information, like people that shows the desperation of people for wanting pure drinking water. Like people who are having like 30,000 or like 35,000 of a monthly income, they are kind of spending around like 1,000 of their income just for the buying of that safe drinking water. And this problem is very, severe in the lower income community, for particularly this sort of areas where they have to contribute a huge percentage of their water for that water expense. For example, if we have gone to some places, some households where the monthly income of that household is like only 10,000, BDT, but they have to around spend like 500 to 600 Bangladeshi taka for the purchase of monthly water expenses. So that's very crucial. So in one side, they have to pay more for the safe drinking water. And on the other side, they are not getting that expected water quality that they should have got. So those key insights were like very important for us, and we understand the need and the demand of our users, that they want to spend less. So they want affordable solution, and they want a solution that will be sustainable in terms of the water quality. So that's how we designed our feasibility study of the solar desalination device from two perspectives. The first one is a social perspective. So we wanted to understand like what's people's perception of adopting the solar desalination device, because from that market study and the field service, we have understood the need of a proper solution that will be replaced for the people, for the need of that pure drinking water, because the desperation shows in the data of their monthly expense for the water. And secondly, we wanted to capture like the feedback about the water quality and quantity for the usage of solar desalination device from our users who are using that, solar desalination device and drinking the water from this device. And the third one is like from a technical perspective, because the user may think like the water is drinkable, but some of those water quality parameter may not satisfy that particular water that they're drinking. So we wanted to ensure, like from the lab testing, that they are drinking the exact, the proper quality of water according to the standards. So how we just tested the feasibility study. So in terms of like social perspective. So first, in the first place, we wanted to capture the perception of adopting social desalination device for the users. And secondly, we wanted to catch the perception of our users after using the solar desalination device. So that before and after, part was like the main essence of capturing the perspective, solar for the feasibility study of the solar desalination device. So for the first step, we understood the water problem of that particular households who actually complained about the water quality that they are having right now, and also complained about the expenses that they are bearing. So we try to inform those people about like the effect of drinking the saline water that they are consuming for years. And after that, we introduced the solar desalination device, the concept, like how it works and how they can have like affordable and the safe desalinated drinking water in their household itself. And after that, we try to ask them if they're willing to adopt that. So that was the first part of that study, where we try to capture the understanding or like acceptance towards a new technology, because in those areas, people are kind of not that much aware and educated about those new technologies. So there are a lot of trust factors involved in that process. So we wanted to capture like how adopting or flexible they are towards a new technology. So that was the first step. And the second step, we tried to just settle or like set up some of our solar desalination devices in 19 households. And we tried to collect the water quality and quantity data, like how much water is producing, if it is fulfilling their water demands for their family needs or not, how the water quality, taste, and odor of the water is looking like. We try to collect those water quality and quantity data for around 6 months from this 19 households. So that was the second part of that feasibility study, where we tried to understand the perspective from the users after using the water from our desalination device. So talking about the first, part of that study, where we tried to understand people's perception, and we found very surprising information. So we knew very well that people are suffering from that salinity problem. They are not happy about the water quality of the sources they are currently using, and they're also spending a lot of money. But they have some interesting perspective towards adopting a new technology. So as you can see, like when we introduced that water desalination device, and we wanted to ask them like if they are willing to take that device. So if it was asked to somebody in in some of those city areas like Dhaka or like Chittagong and the big cities, people may have been interested to just try it out for the first time. But in those remote coastal communities, people have a perspective where we could see the lack of trust, education, and awareness of the potential health hazards from like drinking those saline water. And I think that's why we got this interesting data sets, where immediately only 20% of the people wanted to adopt that. And around like 79% people was like say that they are not sure right now to jump into that conclusion if they want to adopt it or not. So they wanted some of those validation. They didn't want to be the first person to adopt that device. And only 1% said that they does not want that device right now. And they are the people who are kind of living in the less salinity affected zone. So the interesting perspective that we have got, like the educational perspective, that the education level and the awareness from that community is not that much high as like the city dwellers. So there is a just a factor of trust towards a new technology that is a potential cause of not adopting that device from the very first place. And I think that was the reason of their being skeptical about like new technologies. So our key understanding was that like a lot of seminars or like workshops or like community engagement could have been a very helpful tool in order to building that awareness and trust for such products. And if we can, just show them some of the results, like see, this is the water quality, and here you can use this water because your neighbors are using it. So if they see some of those results and those community one-on-one engagement, seminars, workshops, that can be very helpful to change that percentage reversely. So after having that understanding, we have understood like what should be the future steps in order to increase the awareness. But for the second part of the study, where we set up those devices in 19 households, we tried to capture the water quality and quantity data from the user's perspective, who agreed to just step up and wanted our device to be installed in their home. So we tried to understand their perspective, if they're satisfied or not satisfied with the water quality and quantity. So there has been no complaint registered about the quantity of the water. So as we claimed, like a member of 5 to 6 people, perhaps more than that, we have one household that had like 8 to 10 members. So even for that family, the water quantity was more than enough for them to drink. And the device could actually produce like that, just enough quantity of water according to the water demand of that families. So no complaint were registered about the water quantity, but 68% of the users expressed satisfaction regarding the water quality, because the 32% people who reported unsatisfaction, basically we found out an interesting fact, like we basically tried to address the salinity problem that is present in the water. But we have a diversification of water problems in the coastal region of Bangladesh, and another important parameter of them is like high iron quantity. So the device was basically designed in a way where the reverse osmosis system was like highlighted the most, and it basically can remove all the salts from there. But for the reduction of the iron quantity, that PPF filter and the CTO filter can remove it a little bit. But if the iron concentration is like really high, so that particular water is desalinated, but the iron quantity is kind of still present in that output water. So that's why I think 32% of the people have like expressed their concern about the water quality. So right now our team is like working on that particular scenario, if like apart from the salt and salinity, if some of the other parameter of the water is particularly intriguing or like a concern for a particular area, our device can be customized based on the demand of that particular household or the community of that users. So that was it about the social perspective, how our people and the users express the satisfaction and unsatisfaction based on the output water. But we wanted to test those water quality parameters from the labs as well, in order to understand if they are under the acceptable drinkable limits from the WHO and the ECR standard of Bangladesh. And after testing some of those samples from our devices, we have got that understanding around the pH is not a very big problem for that water. So around the drinkable limits for that pH is around 6.5 to 8.5. So mostly our output water's pH remains around 7.5, which is very good. And for the TDS, so this particular parameter, total dissolved solids, actually varies from areas to areas in Khulna. Some of those areas, the TDS of the water is very high, and some of those areas, the TDS of the water is less. So depending on the TDS amount, the filtration unit, one filtration unit of ours needs to be changed, or like just changed on a regular basis or not. This factor determines that. So the water output water quality that we have tested after the desalination procedures is around like 300 to 400, so which is way under the acceptable limits of that what TDS parameter. And the important part was like the chloride ion concentration as well. So the acceptable limit for this is 250 milligram per liter, where around the test result shows our sample had 212 milligram per liter. And the total iron, the acceptable limit is 0.3 to 1.0. So in the less, iron affected areas, mostly where salinity is the problem, iron concentration is not that high. So we have got like 0.01 milligram per liter, which is very under the very, acceptable limits. But where the iron concentration of the input water is very high, so some of those samples had like the iron concentration that is more than this acceptable limits. So we are currently trying to troubleshoot that particular parameter. So for a conclusion from this test results, we would say like the output water from the desalination device satisfied the acceptable limits for the drinking water. We have tried to show a comparison of the water quality of the existing sources versus the output water of our solar desalination device. So we could see like the pH does not vary that much in that area. So the available existing sources pH is kind of similar to our pH of the solar desalination device. But the main problem or the main disparity is that our device is solving is to decreasing the TDS and the salt concentrations basically. So according to the data sets that I have got, the TDS or the total dissolved solids that's present in currently in those areas, if we take an average, it will be around like 1500 milligram per liter, where our water output water's quality TDS is way lower than that, and it's under 400. So that's how we are kind of removing the dissolved solids to a great extent from our device. And for the salt concentration, chloride concentration, because that part is like, as I have shown in my first slide, the average, salt concentration or like salinity concentration is like 1000 milligram per liter. But in some of those high saline zone that where we have worked, we have seen that salinity is kind of touching 2000 milligram per liter as well, which is very concerning, and which is the main impact of the adverse health impacts for that community people. But with our device, we could, decrease that around like at a range of 250 milligram per liter, which is in the acceptable limit of the drinkable water criteria. So apart from that, our CTO and PPF filter unit is also able to remove the total iron concentration to a small extent. And you can see like on an average in some of those areas, there is like 3 milligram per liter iron concentration, which is much more. But in maximum from the average data set, we have found like 2 milligram per liter iron concentration, and our device can offer like an iron concentration that is around within a limit of 0.01 to 0.05 milligram per liter. So comparing the water quality parameters, we would say we are addressing and giving our just proposing and offering the community leaders a very unique and improvised quality of water, where we are removing the TDS, the salts, and also iron to a great extent. So that was the comparison basically that right now the people are consuming and what we can offer from our solar desalination device. So coming to the conclusion of our whole study, we have understood like around 61% people right now from our primary database of 201 households of people in Khulna, that they are not satisfied with the existing water quality, and they are paying around like 2 to 5% of their monthly income just for like that drinking water expense. So which is very high for this low income people. And it indicates like the desperately needs significant and sustainable solution for that water salinity problem. And our second findings were like about the unique nature of the people for adapting new technologies. So around like 79% people was not at first sure for adopting the new technologies like solar desalination device. They needed a proof of, a validation from like word of mouth of like different users who have used that particular technology before, or people who can make them understand and create that awareness and trust for that particular technology. So for particularly that, I think conclusion, we have understood the importance of conducting seminars, research, and like webinars within this community people and build that awareness and trust for that particular new technologies. And the usage of like the data sets from our users about the water quality and quantity of solar desalination device, we have got overall a very positive response that we expected. So no complaints were like filed for the water quantity of that device, but 68% people have expressed like the positive response in terms of water quality as well. And the water quality parameters that has been identified as a concern, we are also working on that in order to improve that and particularly incorporate that in our filters as well. So, and the last thing, that the output water quality of the solar desalination device also satisfied the acceptable limits for the drinking water as per the ECR standards. So that's how we have, just wrapped up the whole study, where we have understood how severe the salinity problem is from a very field perspective, where we have gone to the fields, our field has collected the data sets, and we have understood the need of alternative solutions for this particular problem. We have also gone to the community members with our devices, tested the devices, took their perspective, and understood the whole scenario of that community members for the adoption of solar desalination device. And lastly, we have tested in terms of technical perspective, how much feasible that solar desalination device will be in terms of just the standards that we have currently in our country, and if it satisfies that. So holistically, I can say that this solar desalination device can be regarded as a very feasible and sustainable solution for the upcoming salinity problem that is going to be increased in the near future. And it can be a promising solution that not only the private limited companies like us, also the government and the NGOs can adopt and use in that coastal communities to solve this salinity problem for long terms. And these are the references that we have used in the studies, where you can see the data sets that I have shown already to you. And at the end of my, I think, presentation, thank you all for being a great audience and to listen to me up to this point. And I'd like to acknowledge Tetra as the, for the funding partner for this research, and my team, who has been a great contributors for this study. Farha bint Firoz, Asif Hussain, Mubashir Tahmed, Sabir Karim Rudro, Maria Akhtar, Zubair Hassan, and Anika Nawar Mim for helping with the data sets, collection, analysis, and also conducting the feasibility study of this research. So thank you, everyone. I think that is all from me. If you have any questions, I'd be glad to answer.
Thank you, Ms. Sabrina, for your tremendous presentation on this critical issue of addressing salinity problem in drinking water quality in coastal Bangladesh, and also sharing your field research experience with us. Your research demands that collective action is necessary from scholars community to the concerned authorities to tackle this issue. Now, we'll move forward to the question and answer session. I'm requesting the audience to raise their hands if they have any questions, and I will give you the floor one by one. Miss Sabrina, would you prefer to take all questions and address them together, or would you like to go one by one?
I think one by one would be good because it will help us to, just have that flow from that audience.
Sure, we'll go with your preferences. I'm requesting everyone to raise their questions, to raise their hands by Zoom, and I will come to you one by one.
May I ask one question? Do you hear me?
Yes, please raise your queries.
So my question is, how did you select the location of your study? Was it randomized control trial or purposive sample? And so I think there is a selection bias in your sample. So without randomizing the what is it called, your sample, it is very difficult to come to some conclusion. So what's your comment in that case?
Okay, thank you so much for that question. Basically, I think in the study area slide, we have shown like we have reviewed a little bit of previous research that has been shown like which are the basically most salinity affected zones in the coastal community, coastal region of Bangladesh. So under that particular, based on that particular outcome of those researchers, we have selected the study areas where we put our specific emphasis, and based on that, we tried to select those households accordingly. So if you, there has been published research for this particular paper. So if you go through that, we have mentioned that studies where we have marked like which references we have used and from which studies we have got these data sets, like which are the most, I think, severely salinity affected zones. And we wanted to, we didn't randomize it, rather we tried to adjust our household data sets and the correspondence and also from the water sampling according to that ratio. So I hope that answers your question. Sorry,
so I have one more. I have one more question. So you said that this is a cost-effective reverse osmosis process, right? So there are also another what is it called, system, rainwater harvesting. This is also cheaper. And you mentioned that the water could be contaminated during the course of time. So also you mentioned that your system is not, what is it called, validated by the local participants, and also it is not effective where iron contamination is high. So what do you think? So overall, which one is how the trade-off? Whether they will consume what is it called, the iron content water, or they prefer less, what is it called, expensive rainwater harvesting. So do you have any idea on that?
Yeah, sure. Absolutely. I do have that idea. So thank you for your question. That's a very interesting question as well, because whenever we try to implement some of those technologies, we try to, understand the pros and cons of every technology. So we are not saying like the existing solutions, like those are not, acceptable at all. Rainwater harvesting has its own, usefulness as well. But the problems that we tried to solve was not solved by that particular solution. So rainwater harvesting's problem is like there is a high chances of contamination, bacterial contamination, and other virus contamination as well. So from that perspective, we wanted to ensure a water source that can have the flow of water, or that can generate the flow of water in a regular basis, so that they don't need to store that water. Now, coming to the second point that you have wanted to understand, the trade-off between the expenses and other stuffs. So if you if we want to break down the cost, so there is not only the initial cost that's involved, there is like OMN cost, like the operational and maintenance cost. And as I've said, the contamination chances, if as that's high in the rainwater harvesting system, the operational cost makes that unit cost or unit price of water a little bit higher. And the same goes for the desalination plants water, because for the desalination plant, the unit production rate of the water is low, but the transportation and the distribution makes the unit cost of water high. So I can give you one data set. Like currently, that coastal community of people on an average spend like around 1 to 2 taka per liter in the remote places where they need to transport that water. But our devices, as it's a household device, you don't need to transport it. So that can provide a unit cost of 0.5 taka per liter. So that's how we are claiming that the particularly that unit rate of water is less. And I have already shown you the unit price of that particular solar desalination device, but that is not equal to the unit cost of the production of the water that you are consuming. Because if you see from an annual perspective, the amount of water is generating and the cost involved in that, you have to divide it with the amount of water, and that how you can get like the unit cost of that particular liter of water. And that's how we are claiming that we are an affordable and this cost-effective solution, not with only the price of that particular desalination device, because our desalination device may cost a little bit extra for the initial, just purchasing. But in terms of operational cost involved, we are way cheaper than the systems that you are comparing to. So that's how we would say, like, the trade-offs has to be considered with a lot of parameters, not only the first production or the implementation cost, rather it involves the operational maintenance cost, the technical, features, and also the user's perspective. And the third thing that you have said, like how I see it, as it's having an issue with the iron concentration. So basically, I should have showed actually some maps with along with the salinity concentration and the iron concentration. So in Khulna, in some of those areas, the iron concentration is not uniformly or spatially distributed throughout Khulna or the coastal region. In some of those places, there is like high iron concentration. So what our unique proposition is like, basically we are a private limited company, so we can customize our devices based on the particular need of our customer. So in some of those areas, the iron concentration is way low. So you should not use that, high filtration iron filter in your device. But where the iron concentration is higher, we are proposing and incorporating that particular filter in for particularly that household where the iron concentration is high. So we are addressing that problem with a customized based approach, where we are not incorporating like that high expensive iron filter unit for all the devices. Rather, we are customizing it based on the needs, because we have found not only the iron is a parameter, because our devices actually remove the TDS quite well. So the TDS also varies, especially in that particular region. So the TDS is not actually stable, or you cannot range it in a very limited range. So it has spatially varied a lot in that region. So talking about iron, TDS, or the other parameter that varies, we have very customized solution. If I summarize, but for the average problem that resides in the coastal belt, the salinity one, our product is actually a very good way of like solving that problem in comparison to the other ones. So I hope I have answered your question. Thank you.
Thank you very much. Thank you.
Thank you for the question and addressing the question so gracefully, Miss Sabrina. Now I will move forward, and I would like to request the audience, before asking any question, please mention your name and profession. Then please raise your question. Now, I'd like to request Jimim Abrar Janvi to raise his question.
Hello.
Hello. Assalamu alaikum.
Walaikum assalam. My name is Janvi. I'm a fresh graduate from Islamic University of Technology. I'm working as a junior engineer in BC Associates Limited. My question is what's basically similar to the previous guy. So it was is there any particular reason of choosing Khulna as the study area as there are also other high risk areas suffering from salinity problem? You have already answered that. So is there any chance, do you have a future plan to investigate the situation in other areas too? Aside from
absolutely. That was your only question?
Yeah.
Okay. So yes, absolutely. Why not? Like we wanted to target basically the high salinity impact zone at the very first place, because if the solution works there, it should work in the other place as well. So that's why we started with Khulna, but we are working in the other regions of the coastal belt as well. And we want to, just implement that solution throughout the coastal regions where there is salinity problem. So yes, I think pretty much we are open to that.
Okay, thank you.
Thank you. Moving forward, I will now request Dr. Sultan Ahmed to raise his question.
Thank you so much, Nafisa, and congratulations, Sabrina, for this great work. And we are thankful that you agreed to present your work on our research platform. I have a few queries. Number one is, what is the maximum PPT of raw water, and what are the sources of raw water that is being used in your device? And what is the availability of membrane for river osmosis process? Whether it is available in Bangladesh or who will supply? And okay. And the other one is how many solar panels? Because you have mentioned that is something 4 point some kilowatt of I'm sure. So how many solar panels you need to produce that amount of electricity, and then whether there is any provision for solar versus grid. I mean, whether there will be an alternative if solar power is not available due to the weather condition, whether the device can be connected with grid power, whether there will be any provision there. And I have the last query about the environment. You see, after desalination, there will be some reject. I would say that is this brine water. How to dispose of that brine water, and there will be battery. Maybe it is a liquid battery. I am not sure. Could be a liquid battery or dry battery. What will be the disposal of the, expired battery? And because every device will be having one battery, so what will be the disposal? Do you have any disposal guideline, or because the Department of Environment has got some regulation for this battery disposal? So thank you once again for this great presentation. I wish that people will, not only the coastal zone people, this device, even in the urban areas we can use because it is a single unit. So I hope that your work will be greatly appreciated and will be taken in the household for solution of drinking water in the coastal zone of Bangladesh. Thank you so much.
Thank you so much for your questions, and it's been a pleasure to present here, honestly. So if I just start just replying your questions. So the first question of yours was like, what was the PPT or like concentration of salinity for that input water? So that's like kind of, I have shown in the last slide, like the existing water quality actually varies a lot in that particular area. So if you just try to ask me like what was the particular salinity concentration that we were working with, so around like we tried to work with in the range of like 1,000 to 2,000 ppt or milligram per liter of salinity where there is present in the groundwater and surface water sources. So the second question of yours was like, what are the sources that we were using for the input water? That's basically the sources that is available in the proximity of that households. Basically, that can be the surface water or groundwater that is salinity, affected, but actually the water quantity was not a problem for that area. The water quality was. So we are using that available water sources like the ponds or like the tube wells that is available in the proximity of the households, and that are like transported with a pipeline as an input water of that device. And we use that water source to, just desalinate the water and to make it drinkable. And addressing your third question about the membrane availability, I think the membranes that we are using right now, we are sourcing it locally, but they're the main manufacturers are I think they are transporting it from China and Taiwan. So in terms of like the availability right now, I would say currently the market is stable, and we have the availability of the membranes quite a few. So we don't have that lack of membranes still now. And as we are not the manufacturer of that particular filter membranes, so we are not actually have plans right now in the current future to produce that membrane, within our company. We are outsourcing that. So I think in terms of the membrane quality and the availability, we're trying to make sure that we are using the proper membranes and which is the best for like our device. I think the next question was about how many solar panels do you need to generate that 4.32 kilowatt hour just energy consumption. So right now, I think I have shown you the size of that solar panel as well. So as you know, like the solar panel has its own features as well. So depending on the climate and the other, sunshine hours, it can produce different amount of energy. So right now we are just attaching one solar panel to our device that is basically constructed or set up in the rooftop of that building, and it's connected to our device in order to produce or like pass that energy within the battery that where it stores and where it is used. So basically right now, according to our current design standard, one solar panel is kind of enough to fulfill the, just the water demand for that particular family. But yes, if like we are, proposing that particular device for some families or like particular cluster of community, the solar panel units needs to be increased for sure. The next question was like the solar versus grid. So currently we are acquiring all the energy from the solar panels. We are not connected with any grids, but if there is any, community-based solutions that we might propose in the future, we can have those grids connected and can get those electricity or the power consumption from the grids as solar grids as well. But right now, as we are proposing a household-based solutions, so we are good with the power from the solar panel. And the last one was the environmental impact of the brine and disposal of the batteries. So yes, currently that has been always a very challenging thing to manage that brine management and the disposals of the stuffs. So as you know, like that brine is basically for who are not aware with that particular terminology. Brine is like the high concentrated salt water. Basically, we try to remove the salt from the water, and the salt has to be disposed in some way, right? So that's how the in our output wastage bin. So that salt has been just stored in that area, And from time to time, we have to maintain it. We have to remove it from the device and have to dispose it. So currently we are thinking like, because as Brian has some of those environmental impacts, and we are trying to, just proposing an environmental friendly solutions. So we were thinking like wire brines can be used for some other businesses. So we have found like in some of the shrimp culture and some of those other areas where high salt water or like the brines are, used. So we are trying to just take that wastage and try to produce it or mold it in a certain way that can be used in the other, businesses as well, where it can be treated not as a wastage, but as a byproduct for the other businesses. But currently that has been stored in a particular unit of our device, and time to time we have to take it out and have to recycle it. So that's how our management of like Brian works right now. I think I have answered all of
No,
that.
what is about the battery disposal?
So for the battery disposal, if like that battery, we are purchasing that battery with a warranty of some lifetime from our manufacturer and vendors. So after like the battery is dead, we are communicating with them for the disposal, and they are right now in a partnership contract with us for the disposal thing. So basically what we do after that, if the lifetime of the battery is like finished, so we are currently handing it over to them and trying to transport it with the vendors. So we are currently kind of partnering with that vendor communities in order to dispose that battery in according to the standard of our environmental organizations.
Thank you so much.
Thank you. Yeah.
Thank you, sir, and Sabrina, for this amazing discussion. I can see hand is raised in the chat box. I'd like to call Dr. Mohammad Abu Saim Jiku. If you have any questions, please raise it.
Thank you, Sabrina Rashid, for your nice presentations. And I think this is the good topic you already discussed here. And today, just a little one, I know, just the desalination is the good word. Just solar desalination device you can use. Just I want to know, just solar desalination is feasible for large scale in Khulna district in Bangladesh, or any others already done? Have any example? Just please mention. Thank you.
Yeah, thank you so much for your question. Actually, we have implemented one of our community-based solar desalination device recently in last March. So that has been under like our observation. So if I talk very clearly, one of the key problems that we wanted to solve, that the users don't need to travel a long way to collect water. So that's why we tried to propose some of those household-based solutions. But the community-based solutions, if like the user has to walk like 1-2 kilometers to collect water, that is not solving our one of the core purpose or like the problem statement that we are addressing. So we wanted, or we are proposing a community-based solutions only where there is cluster of households. For example, in like 500 meter or 1 kilometer of proximity, or in the radius of that circle, we have like 10 to 12 households together living. So if that is the case, so their community-based solutions can be definitely implemented, and we have already, just constructed one of our community-based devices there. And that is, of course, has to be big in size because the water demand will be higher, and the unit daily rate productions needs to be higher as well. So yes, definitely they are on that process to, getting implemented. And you have asked about if someone else has already implemented that. According to my knowledge, as per my knowledge, I think the government, authorities try to have some of those expensive desalination plants, but those are very little on numbers. And that does not solve the problem of like high travel, traveling areas daily for the women and the girls. So I think That's how we are observing the problem that we want to solve, that traveling problem for the collection of drinking water. And I think where there is feasibility or like suitability of like implementing a community-based device, we are already considering that.
Okay, thank you.
Thanks.
Thank you for the question. And I'm requesting for the last time, if anybody has any question, please raise your hands. Okay, so now I would like to request Dr. Mohammed Tariq to raise his question.
My heartfelt thanks to Sabrina for I think it is a very crisp, clear, and to the point presentation.
Thank you.
And in fact, for last half an hour, you have answered all the issues and many issues already raised. I work at BIGM and I belong to a district which is adjacent to Khulna, is Bagherat.
Oh.
So I am very much familiar with the issue and the problem. My kind of comments or question could be, you have already answered, but I want some feedback from you on 3 issues. One is going back to sampling. Do you have any sort of intention to have some more samples and get feedback from the all through coastal area that will give you may give you more information. Second is, you already pointed out in your study that other than salinity, that is the main issue, but there is this iron contents, and what are the other type of particles there could be in the water that is not addressed by your device. And my third kind of observation is that you talk that your price per liter is 0.5 taka. But there is an initial investment cost and running cost. And given the life of your device, you haven't shown anywhere in your presentation that what is the basic, why a person will accept it if you cannot show that your cost is really less than the market cost that people are presently incurring. And how you can, what is your kind of thinking that you can make people, the acceptance rate at this point is only 20% as per your. So how you think that you can raise this acceptance of people more towards this kind of device? Thank you. Thank you again.
Yeah, thank you so much for your questions. So yes, like the first question is about sampling. If we are considering more sampling to understand like the scenario in a broader perspective, yes, of course, we are currently in the process of collecting more samples for the lab testing and also from our users' perspective, because we wanted to also see the seasonal variations from the device. So yes, we are collecting more samples, and in the next studies, hopefully I can present those results to you as well. And the second question is about like if there is other parameters rather than iron that we have identified and that cannot be solved from the first prototype of our device. So yes, as I said, the unique feature of that particular area is like the water parameters are like spatially varying in that small area as well. So the iron concentration is like some of those areas that is higher. So the other parameters like the TDS and the like TDS is another parameter that is also spatially varying in some areas. But we had approached that problem from the very starting of our, making solutions. So TDS and salt, that two parameters can be removed by our filter very well. And for the unique feature of iron, because the iron concentration is not that much higher in all the region of that coastal belt, but rather in some of those areas, it is higher than the very usual amount. So particularly for that areas, we are customizing our solutions, as I have mentioned earlier. So that's the question for the second one. The third one, you have asked for the breakdown of the cost and the prices. So yeah, I should have added another slide maybe. We used to add that slide in the business, competitions or the pitch deck, where we showed like the price breakdown. But as it was a research webinar, I thought like just showing up a lot of numbers or like the financial cost estimates might bore the type of audience that are present here. But yeah, I'd like to have some of those, breakdowns in my answers. So basically the unit cost of the water, basically, you can just analyze it based on some parameters. The first parameter is definitely the production cost. That's the one-time value or like the cost that you are paying for that solution. For example, how much you are paying for that solar desalination device. That's the cost of like this particular solution. If you are, implementing a rainwater harvesting system, what's the installation cost of that storage or like the whole system? So that's one type of cost. The second type of cost is we say it O&M cost. That's operational and maintenance cost. That is also a very important feature if you want to calculate the unit cost of water for a long time. So for like the O&M cost is very high for the rainwater harvesting system, but for our filters, it's not that much high, because only time to time the brine needs to be just collected, and the filtration units based on your usage, because if you have low or less community members and your water demand is less, you are using that device not its highest efficiency, the filtration units work for long. But if you are using it for like as I said, at its highest capacity, you'll need like 1000 BDT or like 1200 BDT max for the change of that filters annually. So the O&M cost is like, if you consider it like monthly basis, it's like less than 100 taka per month. So which is like quite affordable in comparison with the other solutions. And the third cost involved is like the transportation cost and the distribution cost that is associated with a lot of solutions there. Because when an installation of a product or a solution is very expensive, you cannot install it in every household, right? So people have to collect water, or you have to have some of those three-puller rickshaws or the other vendors to collect or transport those water. As you are from the coastal belt, I think you have seen like the big chunk of bottles that has been transported with the taxis or like the vans we have seen. So you have to pay a payment for that, I think, rickshaw puller for that particular cart. So it increases the unit cost of, water. So from that breakdown, we have found out like currently the coastal region of people around paying 0.8 to around 2 taka BDT per liter, where as our solution is home-based, we are proposing as a unit cost of 0.5 taka per solution. So that's how like our numbers has been, we have got that numbers. And like the last question was about like, yes, as there has been a great number of people, around like 20%, who have accepted like very graciously at the very first attempt to use our product. But a lot of people who have been unsure, like they're not sure, like, yeah, we want to do it, we don't want to do it. They're unsure about like adopting a new technology. So we have understand the skeptical nature of those community people because of the lack of trust and awareness of that severity of the problem. Because consuming that saline water does not make you sick at the very first place. It has long-term impacts. So understanding that long-term impacts and educating them with those resources is very important. That's what we feel. And that's why we are proposing to conduct awareness campaigns and like some of those webinars in those communities. That's very important to have that trust. And also understanding that importance of these campaigns, we have already launched a project called Project Nirapod, where we, in community basis, we are going, our field team is like an excellent field team we have got a lot of volunteers. So they are going places to places in some communities, gathering people, educating them with proper resources and trainings. And I think that raising awareness part has been already addressed, and we are on the verge of, doing it continuously. So I think, yeah, that's it from my side.
Thank you.
Thank you to our Honorable Director, Sir, and Ms. Sabrina for this insightful and a deeper discussion. Now we have come to the end of today's webinar. Dear audience, I would like to thank everyone for joining the webinar and your encouraging participation. Lastly, I would like to give thanks again to our speaker, Ms. Sabrina, for her valuable time and sharing her tremendous research knowledge through this platform. Wish you the best for your future endeavors on the behalf of VIGM and Reform. Dear audience, I would also like to invite you to stay connected with Reform through social media platforms and our YouTube channel. Please keep connected to get notified about our next webinar. And lastly, I would thanks again for everyone's encouraging participation. And with this, now I would like to conclude today's webinar. Thank you.
Thank you so much, Nafisa, for your wonderful hosting. And thank you everyone for having me here today.
Thank you. Thank you again.
Thank you so much.
And thank you all.
Thank you, sir. Thank you.
Thank you, Tariq sir. Thank you,
Thank you,
Sabrina.
sir.
Thank you, BIGM,
Thank you. Thank you very much.
for arranging this type of valuable seminar.
যারা কয় মিনিট আছে আপনার যাদের শেষ হয়ে গেছে একটা অ্যানাউন্সমেন্ট আছে আর 10 মিনিট বসেন ঠিক আছে